Okay, now let's talk about how we study development. So there are lots of different tools that you can use to study development. You can do naturalistic observations, you can do surveys, you can do physiological measures like heart rate or blood sugar level, things like that. You can do standardized tests. So there's lots of different tools that you can use to measure whatever it is that you're measuring. When it comes to the design of the study, so the research methods, there are three basic types: descriptive, correlational, and experimental. Descriptive research is called that because all you're doing is describing what you see or what's going on. You're just observing and recording behavior. There's no attempt to explain why you're seeing what you're seeing or predict anything or anything like that. You're just saying what you see. So, for example, if you're just saying, okay, well, in this group of participants, 25% were aged 36 to 45, 30% were aged 26 to 35, and 45% were 16 to 25. That's all you're saying. That's all you're saying. You're just describing what's there. You're not trying to explain why there's that particular makeup or anything like that. Okay, so it's just descriptive, and this is generally very early research where you're just trying to get a lay of the land. Then there's correlational research. With correlational research, you're just getting a sense of the strength of the relationship between two or more events or characteristics. So you're just seeing whether or not one thing tends to be accompanied by another thing. That does not mean that one thing causes the other. Okay, so two things can be correlated, but that doesn't necessarily mean that one thing causes the other. They could be related to some third thing that's completely off to the side. It's like it's just a coincidence that they're related, for example. But it can give you some clues as to other things that might be going on. When you have a correlation, the correlation coefficient describes the strength of that relationship. So it can range from -1 to +1. And basically, 0 is no correlation. And then the further you get to either -1 or +1, the stronger the correlation it is. Okay, so a -1 correlation and a +1 correlation are both equally strong. Okay, they're both equally strong. It's just that the negative and positive only refers to the direction of that relationship. So in a negative relationship, as one thing increases, the other thing decreases. Okay, so I'm trying to think of examples, but just the number of parties you went to in a week. As that increases, your score. Do I have this? Did I just make? Okay. As one thing, so the more parties you went to in a week, the lower your score was on your exam at the end of that week. Okay, that would be an example. So here, these little dots right here, this person went to a whole bunch of parties. And if this axis right here was their score on the exam at the end of that week, you'll see that that's towards the lower end. So that's just, I don't know, just coming up with weird examples. But there's a fairly strong relationship here. We have a -0.8. I'm just making these numbers up. Over here you have a positive relationship, just as strong as you can see from the clustering of the points there. But here that might be, for example, the relationship between how much you studied, how many hours you studied, and how well you did on the exam. Okay, so as one goes up, the other goes up. So here you have people that studied a lot, and they studied for a lot of hours, and they had higher grades on the exam. Here you had people who barely studied at all, and they didn't do so great on the exam. Okay, so that's just as one thing goes up, the other thing goes up, and that's a positive relationship. In a negative relationship, as the amount of one thing goes up, the amount of the other thing goes down. And then no correlation means there's no correlation. There is no relationship between these two things. So the amount of your favorite color has no correlation with your grades. Okay, no correlation there. And then there are experiments. Now, experiments are great if you can do them. However, you can't always ethically do them. But if you can, then this is what you would use in order to determine a cause and effect relationship between two variables. So again, correlations are just describing a relationship in terms of like when you see one, you tend to see changes in the other. But you're not controlling that change. You know, it could just be coincidental. With an experiment, you're in control. So you have an independent variable, which is something that you manipulate and control, and then you have a dependent variable, which is the thing that you measure to see if it changed as a result of your manipulation. So you're trying to see what is the effect of the independent variable on the dependent variable. So let's say that you think that you've discovered a vaccine for Alzheimer's disease, okay? And you think that there is a cause and effect relationship between whether someone gets the vaccine and whether or not they get Alzheimer's disease. So what is the effect of the vaccine on the incidence of Alzheimer's disease? The dependent variable is the variable that may or may not change in response to the manipulations of the independent variable. So whether or not it changes depends on whether or not the independent variable causes it to change. So whether someone gets or doesn't get Alzheimer's disease should depend on whether or not they received the vaccine. The vaccine is the independent variable. You manipulate whether or not they receive the vaccine. So some people you give it, some people they get a placebo, for example. And whether or not they get Alzheimer's disease should be different depending upon whether or not they got the vaccine. You've got an experimental group and a control group. So the experimental group is the group that receives special treatment. In this case, the group that receives the actual vaccine. And then you've got a control group, which is the group that does not receive any special treatment. So they either don't receive the vaccine or they receive what is just the typical, what's just typically used as a preventative or treatment for a particular condition. And then if significantly fewer people in the vaccination group develop Alzheimer's disease than the people in the control group, then it can be concluded that the vaccination is effective in preventing Alzheimer's disease. So it's just an example, but that's the general idea. Moving away from like medical examples, let's say that someone is trying to claim that video games cause violent behavior. We're a big gaming family in my household, and so everyone just kind of rolls their eyes at it. It's like, oh, video games cause people to be violent. So let's say that you have two people, you take people, not two people, but you have you randomly assigned people to conditions. So first you randomly assign people to be either in group A or group B, and you make sure that initially everyone is pretty much the same. Like on average, everyone in group A and B are roughly the same, the same ages, same experiences, same mix of men and women, and so forth and so on. Then the experimental manipulation, the independent variable. You have one group play video games, violent video games, and then you have the other group play non-violent video games, and then you have them do this thing where they can, like during the either that game or another game, you give them the opportunity to like hit people with white noise, like through the headphones in some other game where you can kind of like snipe people with white noise, and you see whether or not people who play the violent video games are more likely to hit people with these white noise blasts than people who play the non-violent video game. That would be something that you measure to kind of determine whether or not there's any change. This would just be an example of something that that could be done. Now, one study never proves anything. You can disprove things, but you can't prove things. So it would just be a way of adding to the body of evidence for a particular issue, if you can. With developmental research, you want to look at time span, because obviously if you're talking about development, people develop over time. Of course, that also takes a lot of time. So there are a couple of different ways. There's cross-sectional research and also longitudinal research. And we also sometimes look at cohort effects. So in cross-sectional research, individuals of different ages are compared at one time, so at one point in time. So you might measure the vocabulary of a group of preschoolers, and at the same time you're measuring the vocabulary of a group of 6th graders, and at the same time you're measuring the vocabulary of a group of 12th graders. Okay, so you've got these 3 different groups of 3 different, of 3 different ages. You're comparing all of them at the same time. And so maybe in this case, maybe you're interested in the way people's vocabulary changes over time. All right. So you could do that. One benefit to this is that it is the fastest way to conduct developmental research, because you don't have to wait around for the preschoolers to be 12th graders. You can just do this all at one time. The downside to it is that you don't have really a guarantee of whether or not these are actual developmental changes that you're seeing, as opposed to differences in experiences. So maybe one group of people had a very different educational experience. Maybe a certain educational policy law was passed that would have vastly improved or harmed their vocabulary and reading education. So who knows? So that's what you're kind of sacrificing there by using a cross-sectional approach. So to overcome that, you could use the longitudinal approach. So here you are studying the same individuals over a period of time, and this is usually years. All right. So here you would measure the vocabulary skills of a group of kids in preschool, and then you wait a bunch of years and you measure or you wouldn't wait a bunch of years, but maybe you'd be measuring their vocabulary every year from preschool through 12th grade. Okay, so here you get to compare the same person to themselves at different ages as they grow over time. So you get a much more accurate picture of how development actually occurs within individuals. The downside there is obviously that it does take a long time. It takes years. One of the longest longitudinal studies was something like 80 years long. So I mean, the people that started the study didn't live to see the end of the study. It was a multi-generational effort. It was very impressive. And then there are cohort effects. So with cohort effects, what we're describing here is shared experiences based on a generation or era that you were born in, or some group that you were part of. That there's some time aspect to it. So you might hear, for example, the fall 2020 incoming cohort of freshman students. Okay. So like you were all freshmen at UH in that same year, have that common experience. But the way that you're probably most familiar with cohort effects is things like this, where it's like you might be a 90s kid or things that all 2000 kids will remember and stuff like that. And I love these because it's such a trip down memory lane for me. I'm getting old, so I see some of these both in myself, and then I see some of these for my own kids. I'm like, oh yeah, they're totally into that. But that's what we're referring to with cohort effects, is that people will have these shared experiences, and those shared experiences can have an influence on development for better or for worse.